Hello, welcome. We're in Advanced Algebra 2. Today we are going to do the business about double fractions, which is, I think, an awesome name for something, so I made it up. And adding and subtracting rational expressions. Adding and subtracting is basically tedious. Double fractions should be exciting at first. Let's see, you look at an example like this, and the x and the -5 and the 1 are behaving themselves. But you've got like a 6 over x and a 9 over x squared. Now, what you might hope is that since we're dividing, you think, well, we just kind of invert and multiply. Except you'd have to invert, and this is a little bit tricky, but you'd have to invert the whole denominator, not just the 9 over x squared. If you just inverted 9 over x squared, you'd be like, oh, done. But no, the whole denominator. And so that really, in the end, doesn't make it any better, so it's not a thing to do. Here's what we're going to do instead. Multiply top and bottom by enough to clear both of those denominators. So we're going to multiply top and bottom by x squared. Because x squared, if you make everything have extra x squareds, then the numerator will have enough to cancel the over x, and the denominator will have enough to cancel the over x squared part. This is very similar to how in Algebra 1, and then perhaps occasionally in my class, and certainly in geometry, you would have multiplied top and bottom by like square root of 2 to kind of fix the way the denominator looks. Same basic idea here. You'll see excitement will ensue, of course. So we're going to multiply by x squared, and I'm putting in parentheses to indicate that the entire numerator multiplies by x squared, and the entire denominator multiplies by x squared, which means we have some, what I call rainbow action. It's the distributive property, really, of course. And the same is true for the denominator. It's just only exciting to see it once. Okay, so in the numerator, when we distribute, we have x cubed, and then -5x squared, and then 6x squared over x. In the denominator, it's x squared, and then -9x squared over x. Now, I'm kind of showing this the long style here. You might later on not quite write every tiny bit out. Hey, look at this. The x squared over x means the square and the x cancel, and the x squared over x squared means the x squareds over x squareds cancel, I suppose. So we have x cubed minus 5x squared plus 6x in the numerator, x squared minus 9 in the denominator. And hey, look, it's fixed. And I'm like, yes, it is. And yet you can do more, because if you factor out a common x, common factors, love common factors, in the numerator, then it's quadratic, which means we could try to factor it. And in fact, this one does pretty quickly, x minus 2, x minus 3. The denominator is x minus 3, x plus 3. And so, kapowza! X minus 3 cancel. So it's x times x minus 2 in the numerator, x plus 3 in the denominator. We're done. Okay, so some things to do, little tricks to learn, nothing that should totally blow your mind. But hey, let's do another example, and this time they're going to look a little more different than they did last time. When I say they, I'm talking about those second denominators, those tiny little denominators that are there ruining your day. So x plus 2 and x minus 3 are the denominators we're worried about. So I'm going to multiply the numerator by x plus 2 and x minus 3, and the denominator by x plus 2 and x minus 3. Of course, and I hope that it is obvious, you need to multiply the numerator and denominator by the same thing. The reason why, of course, is that this entire numerator-denominator configuration thing right here, right? That is a very, very, very fancy version of the number 1. But looking at that blue is making me sick, so okay. So it's a very fancy version of the number 1, which doesn't change the value of the expression because it's a 1, and my gosh, why would you care if you multiplied by 1? Okay, now, let's do it. So, the 4 on top gets multiplied by x plus 2 and x minus 3. And here I'm going to save us a little time and kind of take a shortcut. The 12, well, okay, actually -12, is multiplied by x minus 3. And that's because the x plus 2 kind of canceled with a denominator of x plus 2. So I skipped a step on purpose to try to help you notice how you could conceivably skip steps, make it less tedious. Okay, so the denominator, the 2 multiplies by x plus 2 and x minus 3. And the 4 multiplies by x plus 2, because again the x minus 3 was eaten up, canceling away the denominator of x minus 3. Okay, now, good times. Do you see in the numerator, there's an x minus 3 in each term? I can factor that out as a common factor. Now, you don't absolutely have to, but it does save yourself some time. So, again, in the numerator, there's an x minus 3 in the bjgum and bjgum term. So each term has an x minus 3, so I show it as a factored out version there, leaving me with the leftover bits. Now that's something you can do to save yourself some time. If you don't see it, you can expand and multiply the 4 in with the x plus 2 and the x minus 3 and stuff, and that'll work. It won't hurt anybody, no kittens will die, but it's more tedious. In the denominator, there's an x plus 2 here and here, so an x plus 2 in both denominator terms. So an x plus 2 can factor out as a, say it with me now, common factor from the denominator. Again, if you don't see that either, you can expand and simplify. It just takes longer and it's more annoying. Okay, now that leaves me with these huge sets of parentheses, both numerator and denominator, with some stuff in it. I had the leftover 4x plus 2 from the first term, and then negative 12 from the second term in the numerator. The denominator is the 2 and the x minus 3 from the first term, the 4 from the second term. Now, let's go ahead and see what happens if we simplify that out. We got 4x, we got a plus 8 minus 12, so it's really negative 4. We got a 2x minus 6 plus 4, so minus 2. Okay, so we're looking good, except that they both have common factors still, right? There's a 4 we can factor out of the numerator to turn that second term into x minus 1. And a 2 we can factor out of the denominator to turn that second term into x minus 1. And then kapauza, there we go, the x minus 1s cancel. And then we got a 4 and a 2, which reduce. So we're talking about 2 times x minus 3 in the numerator, and just plain x plus 2 in the denominator. Ladies and gentlemen, that is a thing. Boom! All right. If you want to expand it to make it 2x minus 6 in the numerator, you can. Nobody will be upset. Okay, but that's only the second example, and that's only our double fractions. Ha! It's going to get better. Now, here we're adding and subtracting. I think you'll actually find the adding and subtracting to be less annoying to think about, but likely more annoying to do. So we've got a situation here, and I've got these denominators. I've got an x plus 2 and x plus 1. Now, if you remember from adding and subtracting fractions before calculators, you're supposed to have common denominators, and that's true here even when the denominators are algebraic instead of just numeric. And in this case, we're talking about a common denominator of just, just give up and multiply them together. X plus 2 times x plus 1. So we're going to take the first term and multiply it top and bottom by x plus 1. And the second expression, or the second term, the second fraction, whatever, and multiply it top and bottom by x plus 2. I think you likely see why I'm going after this. So the first term has a numerator of x plus 1 and a denominator of, I'm clear about this, both. And the second term has a numerator of x plus 2 and a denominator of both, although I wrote them in different order, but it's multiplying, it's all the same. Hey, they match! Awesome! So, they're the same, which means I can actually add or subtract them, and since it'd be embarrassing if you did it wrong, I will do it for you. We're going to remember that when we're adding or subtracting, when the denominator is already lined up, you just keep the denominator and add or subtract the numerator. So we got x plus 1 minus x plus 2. So I'm going to make it look extra long here. We got x plus 1 minus x minus 2, because the negative and the distributive property and stuff. So then we're talking about, denominator, stay there. Nothing happened in there. We're talking about just negative 1 in the numerator. Boom. Wow. Oops. Got excited. Okay. Yeah, okay, so let's do another one, because, I mean, why would you stop at 1? Here's another one, and here we've got these denominators that kind of look sort of like their cousins, and you're going to see that they're cousins in a way that's closer than you might originally think. Okay, so the first term, the denominator factors into x plus 3 times x minus 3. In the second term, all that negative switchy thingamajig, so you factor out the negative sign and you flip the subtraction around. And the reason for that is the first term doesn't need any changing to its denominator. But the second term, notice how I made it minus overall instead of plus with a negative in the bottom. It's the same thing, of course. The second term, if you just throw in an x plus 3 into the bottom, then you've got yourself a common denominator, so you need to, of course, throw it into the top as well, the numerator. So the first term, I'm just, boy, how many times can I rewrite the same thing? But the second one, you got negative 3 times x plus 3 in the numerator, and then now the denominators match, and oh, joyous day, we got 3x minus 9, because the negative 3 and then negative 3. X plus 3, x minus 3, and then, boom, negative 9 as your numerator. Now that is awesome. You got to admit, like that starts, look out again, and then look at the end. You got 3 minus x, turned around, you got the x squared minus 9, factored, only have to alter the second fraction, not the first. You got to give it up for that fraction. Okay, so, next example. Okay, now, here, oh gosh. Well, I did at least factor the denominator for you. I'll probably stop doing that. Okay, well, here we are. So, let's see here. We got x plus 3 and x minus 2 and x plus 3 and x minus 1. Ooh, here's what we're going to do. I know I'm writing now, but hold on a second. Look at the denominator. That's actually, I should have written that first. X plus 3 and x minus 2 and x minus 1. That makes it all match. But, look at this. In the original left-hand thing here, it didn't have an x minus 1. So we added an x minus 1 top and bottom. I know the bottom's shared, but hold on a second. The original one, the one that orangish, didn't have an x minus 1, so I added an x minus 1 top and bottom. Okay, I'm going to take that orange away because it's kind of gross. Now, if you look in the right-hand stuff, it didn't have an x minus 2. So I add an x minus 2, top and bottom. Again, the bottom is shared, but that's only because once you've made them the same, it doesn't matter really who gets the denominator. They're all the same. So, multiply the numerator and denominator by x minus 2. So I skipped a step here on purpose to try to show you again how you could fairly easily make it a bit better for yourself. And then I ruined all the time saving, at least this time, by talking about it. But obviously in the future, when you're doing it, you probably won't have a conversation with yourself about how awesome you are for having done it. Okay, in the top, meaning the numerator, on the left I've expanded it out. And then on the right I've expanded it out. And then we're going to subtract, because that's what the minus sign means. So, excuse me, I like this. So, the denominators stay the same, and then we have 2x squared minus x squared, 14x minus 9x is 5x, negative 16 minus negative 22 is 6, x squared plus 5x plus 6. Of course, you're like, I gotta factor that. I mean, it's calling to you. So that's x plus 2 times x plus 3. The denominator is x plus 3, x minus 2, x minus, gosh, it's been the same for several minutes. Now, kapow! Bye-bye x plus 3, so it was nice knowing you. And so then my numerator is x plus 2, and my denominator is a factored combination of x minus 2 and x minus 1. And, you know, if you were feeling it, you could expand the denominator, but then again, you know I'm going to eventually make us graph them, and you'd rather have it factored for that. Okay, that was some high, fast action stuff. Basically, Transformers 4. Please, thank you for watching, and the please part was let me know if you have any questions. Goodbye.